way possible.
How about now? There we go. Merry Christmas. A welcome into BOSA flight control. You don't hear those two statements in conjunction very often, but what we're doing this morning is pretty amazing in a space and science context. The James Webb Space Telescope is on the pad and ready to go down in French Guiana 1 hour, 30 minutes from now. The launch of something that has been decades, 30 years in the making, $10 billion in space. You don't have time for more sleep, so hello. Good morning, Fish. The James Webb Space Telescope, a singular, amazing piece of technology that, once it's in position a month from now after its launch and everything goes well with all of its mirror deployments and everything, is going to be something pretty significant for us on Earth. For the past several decades, we've enjoyed visual images from the Hubble's telescope, and as the last 2 years have really shown us, Hubble is showing its age. It is a telescope that is visual light, pretty much that's what it does. It takes pictures of space and it goes back in time pretty significantly to show us those images from our past, and that's just how light travel works. We get to see how modern galaxies have been forming because the light from those events is reaching the instrumentation of Hubble's ability to kind of see that far back in time, if you will, see that light. And Webb is going to give us so much more than that. But the first thing that shouldn't be on your mind is that Webb is a replacement for Hubble. It will be able to do many of the things that Hubble does, but the two instruments, assuming Hubble continues to operate, are going to work in conjunction for some time and from very different places. Hubble's in an Earth orbit position. Webb will not be. The Webb will be at what's called the second Lagrange point, which is this place, this position between the sun and the Earth where the gravitational forces of the sun and the Earth are equal. It's going to sit in this spot, way further away from Earth than we can actually go to, repair the thing. And it's going to sit there to save on fuel. But what Hubble's going to do, or what Webb is going to do for us, is very much more. Hubble can see back into the near infrared spectrum of light, because there's visible light, what we see, photons that illuminate things out there, and then there's mid infrared and far infrared, and Webb is going to let us go back in time further, almost back to see to where the first stars formed from the Big Bang. And that's a huge difference to what Hubble can do. It also isn't only a visual light spectrum telescope. It is an infrared spectrum telescope. Much of its instrumentation is dedicated to seeing an infrared spectrum. And the reason that's hugely important is because when Hubble looks out into space, the stellar dust that's out there is reflecting light back. It is obstructing views. Infrared doesn't do that. Infrared goes right through that stuff. So Webb is going to be able to see, one, through that stellar dust field, if you will, that's out there that makes it difficult for Hubble to get as clear a picture as we'd like. And then it will be able, due to simply more powerful instrumentation, be able to see further back in time. We're going to gain a much better understanding of these questions that we've had forever as human beings, of how this all came to be. And it is a massive deal. It cannot stress enough how big of a deal that the Webb telescope is. And this is just this is from NASA's press kit, their media kit. This is a great representation of what Webb is going to let us do. And there's a couple other graphics in here that I'm going to go through before we get tuned into NASA's pregame. I got about an hour pregame. The other thing is, this is not NASA only. NASA, the European Space Agency, the Canadian Space Agency, and a ton of international partners have worked together on it, in a great testament to what can be done in the pursuit of knowledge when these nations put all their bickering and crap aside and work together on something. Webb is a pretty significant milestone in human science achievement, and I'm really excited, if you can't tell, because I'm wide awake on a Christmas morning, to have a look. So Webb is so big it has to fold up inside the fairing. The rocket is an Arianne 5 this morning, and it actually is inside the fairing, all folded up, all tight. Now, there was an issue, and there's been several slips to this launch. One of the issues was one of the latches that holds Webb in place inside the fairing let go, and they had to bring it all out and do a shakedown and make sure it happened. There was some other issues with the rocket telemetry early on, but those have largely been overcome. So this is where it's going to sit. It's called the L2, the Lagrange point 2, between the Earth and the Sun, where both the Earth and the Sun are exerting the same amount of gravitational force on Webb. So it's not between them, I probably even said that, but it's this position beyond the Earth where the Earth's gravitational pull and the Sun's gravitational pull are equal on Webb. So it's sitting pretty far out. It's going to take this telescope a month to get there. So put that in the context of how long did it take, really. They weren't going the same speed, but how long did it take, perseverance to get to Mars? It took, 8-9 months. It's going to take us 1 month to get Webb where it's going. And along the way, it's going to be doing several things. It's going to be unfolding its primary and secondary mirrors. It's going to be, going through a series of calibrations and certifications with the scientists on Earth to make sure it works. And then it's going to start doing its job. But this is a good idea of what L2, Lagrange point 2, is, referencing the Earth. So it's going to be staying in this. If you imagine that the second hand moving around your watch, an old analog watch, or a watch, that way that second hand moves is in alignment with the Earth and the Sun at all times. It's sitting on the outside of that circle, that orbit, and it's going to be in that same position relative to the Earth and the Sun all the time. And the reason it's done that way is so that they can use way less fuel, right? They don't have to continuously fire the engines on this thing to keep it where they want it to be. It's a predictable path they know it will be on, so they can schedule their science observations based on an understanding of it is pretty much always going to be in this place relative to the Earth and the Sun. And the reason it's important to save on fuel is because Webb's initial mission, believe it or not, is only 5 to 10 years long. Now, we can't get out there and service this thing. There's no craft right now available that if something breaks, we can go out there and fix it like we do with Hubble, and that's a major risk. It's a big dice roll. But the other thing is we can't get out there and refuel it yet. And there have been several private and public agencies that have committed to saying within, the 5 to 10 year mission span, it's got fuel for 10 years if they're judicious, that we will have the ability to remotely go out there and refuel this thing. Like, basically imagine an automated cargo resupply mission like that goes to the shuttle, except it's a big fuel tanker that's going to go out there, mate with the Webb Space Telescope, and refuel its gas tank. If that's true, if they accomplish that, then Webb's mission can be like Hubble's mission. It could be decades. And that's the long-term goal. So I hope we get there, because $10 billion, we'll see how well that works. Because they're still out there flying around in movies and stuff. You're not wrong, Feet. But it's an impressive feat of technology and a big dice roll. We all, for those of us that grew up with Hubble, we realized that there were several missions. Discovery flew several of them to get out there and do work on Hubble. And now that there is no shuttle, we don't have even the capability to go out there and repair Hubble. We don't have the ability to go out there and fix it anymore, which is why when we had to go to these backup computers in the past year, it was like, this is the end for Hubble. So it's even bigger risk. Webb's been tested in the clean room and in the lab, and it all works, right? But what happens whenever it goes through, a pretty significant G-force launch, and then it's out there in space? It's a whole different idea of, is it going to work? So it's a big risk for NASA and ESA and the CSA. So what's inside Webb is pretty cool. There's a camera, just visual light camera. Cameras take pictures of just astronomical objects. Spectrographs are actually what break the light into the colors. So as light comes in, not just visual light, infrared light, it breaks it down into color bands so it can be analyzed. And then chronographs block starlight, allowing observations of the planets that orbit nearby. So it actually has the ability to put its finger over specific points in its observable field and say, that's a star, that's a star, that's a star, and I don't want to look there. Because just like when a bright light shines in your eyes, it becomes harder to see because it floods your field of vision with photons. The Webb can actually blot out with its thumb things it doesn't want to influence its instrumentation. And of course, one of those things that's massively going to influence its instrumentation is the sun, our sun. So it actually has if you look at it, it's always shown flat like this with, the instrumentation pointing at you like this. But it's actually designed to fly like this. With the big flat side is actually, it's like an umbrella for Webb at the beach. It keeps our sun from flooding light into its field of vision. So that flat side is always going to be facing Earth from that L2 point, so that it's always blocking the sun's light from interfering with Webb's instrumentation. So yeah, it is a super smart piece of technology. Now Hubble has, blinders around it. Its mirrors and its intake points to keep that out. But Webb's ability to block our own sunlight's way better. And its ability to block its field flooding object. So it can actually, imagine if someone was looking into our solar system, and what's it going to see? It's going to see the sun from a distance, right? It's not going to see anything else. It's going to see the sun, because the sun's this big, bright thing. The rest of us is just reflecting light off, the sun and other stars, but majorly the sun.
We have uncovered wonders undreamt by our ancestors who first speculated on the nature.
That is the start of the stream from French Guiana.
We've crossed the solar system and sent ships
I have
to the
up
stars.
in multiple places apparently.
But we continue to search. We can't help it. We've crossed the solar system. A central element of
course I
human
do.
future lies far beyond the Earth. If we crave some cosmic purpose, then let us find ourselves a worthy goal.
Carl Sagan is awesome, by the way. That's whose voice that is.
If we crave some cosmic purpose,
You're looking at live
worthy
footage
goal.
of an Ariane 5 rocket in Kourou, French Guiana.
Let me
At the
figure out
very
where this
top
other
of that
window is, because I have
extraordinary
two
machine,
windows.
One of the largest rockets in the world. We find the most ambitious space observatory ever built.
Yeah, so
The James Webb Space
let me figure out where this
Telescope.
is coming from, because I still have a window open
And
somewhere that's got this running.
Today is launch day.
It is launch
From
day.
all of the people all around the world working on today's launch, good morning. Bonjour. Buenos dias. This is live coverage of the historic launch of the James.
Haha, I found it. It was on Twitter. Here we
All
go.
of the people all around the world working on today's launch, good morning. Bonjour. Buenos dias. This is live coverage.
That's a
of the
really good
historic
model of
launch
Webb.
of the James Webb Space Telescope. I'm Michelle Thaler, speaking to you from NASA's Goddard Space Flight Center in Greenbelt, Maryland. And I am very excited to be with you today. Today, the James Webb Space Telescope begins its journey to explore the edge of our observable universe, and its journey into history as well. This launch has been years in the making, and the world has turned out to watch. We'll have a lot to discuss both before and after launch, but let me set the scene for what's going on around us. While I'll be anchoring coverage from here at NASA Goddard, the big stuff happens today here, at the Centre Spatial Guyanais, the Guyana Space Center in French Guiana. This is the main launch site for the European Space Agency, a close partner in this once-in-a-generation mission, and the home of all Ariane launches. Katie Haswell is there at the launch facility and joins me now live via satellite. Okay, how
It's
are things
awesome
in
they have an
Peru?
astronomer presenting this.
Michelle, things are looking really good. The boards are green. The mission
I guarantee you
controllers are
Arianne
focusing
is
hard.
really nervous
The,
about this.
We are go for launch. We've had our eye on the weather last couple of days. The weather's been a little bit inclement, so we're keeping an eye on that. But otherwise, everything's looking absolutely great. And I have to tell you, there is just such a buzz of excitement here in the Mission Control Center. It's a remarkable
So I'm going to bring the
feeling.
volume on this down for a little bit. We'll
Right
go
now
back to
we're
what we were
talking
talking about. We'll have it on the background,
upper stage
just in
of
case
the
something
vehicle.
crazy
It's
happens. But they're
integrated
going
arms called
to keep
cryogenic
talking
arms
through
up
what's
on
going
the
on
stage.
here.
And they pump
Bring
in
the
the
volume
cryogenic
down.
fuel, which has to be kept
Hopefully
very,
it's not
very
too
cold.
loud
So,
over me.
it has to be topped up right until the last minute.
So this is what's going to happen after launch, and I'll bring this up a little bit further so you can see it. There's going to be launch today. Then the sun shield is going to deploy. That's the big side piece that keeps the sun out of Webb's eyes. And then the two mirror deployments are going to happen. That's going to happen across the period of a month. The main mirror and the secondary mirror will deploy, and then the arrival at the L2 Lagrange point. The telescope then has to cool down, continue to cool down so it can actually be used. And then the telescope will be aligned and the instruments calibrated, and we'll get our first images. We're talking like the end of February, or the end of January, early February. We're going to get our first images from Webb. It feels like tomorrow to me, considering how long I've been waiting for Webb to launch. I remember the Webb Space Telescope coming to my attention in an episode of The West Wing, when I was like, is that a real thing? There was an episode where a NASA administrator came to the White House, and they were talking about, yeah, the Webb Telescope's going to be out beyond the moon. And I was like, what? That can't be a thing, because I'd never heard it before. And I started looking into it. I was like, yeah, that really is a thing. We're going to make this telescope. That was years ago. So the idea that, more than 20 years ago, the idea that we're here today is a big deal. Come back over. Just some facts here. Ariane 5 is the launch provider, or the launch vehicle today. It's flying out of French Guiana, which is Europe's spaceport. ESA has invested heavily in Kourou, French Guiana. We've seen some launches go off from there before. Back when OneWeb did their initial launch, we watched that together. The orbit is out there in, as was stated, that L2 Lagrange point. And Lagrange means exactly what I've described. It means a position where two stellar objects exert equal gravitational forces on a position. So that's the place where the sun and the earth are equally influencing that spot. The mass, 13,700 pounds, or basically the size of a full school
Remember
bus.
to clonk that follow
Don't
button.
forget to clonk that follow button. And the 5-year mission, up to 10 years. And 5 years is kind of like we will get this much out of it. Everyone expects to get 10 years out of it. And assuming we get it refueled at some point, develop that technology, we can extend it. Primary mirror has 18 mirror segments. The size of the craft is about the length of a tennis court. There's a microscopic layer of gold, and you actually see the light reflecting off of that. It's not like coated across in gold. There's this beryllium structure that is a part of thing. And I can tell you that the reason beryllium is used is the same reason I used to use a beryllium screwdriver when I would tune audio cab in oscillators, because it's not magnetic. Cannot magnetize beryllium, so it keeps it from becoming ionized, and that's one of the big reasons that beryllium is used as a core material in the Webb telescope. The temperature range, the inner layer, the minimum temperature, the minimum temperature is minus 390 Fahrenheit, which is pretty cold, and the max temperature of the outer layer that it can sustain and operate in is 260 degrees Fahrenheit. That's a big deal because, as you know, as it is, it's not going to ever be directly exposed to the sun on the not sun shield side, but it's still going to be heated as it is exposed to other things. The Earth is also a pretty amazing shield for the light, right? Because there's the sun, there's the Earth, there's the telescope. The Earth and the sun shield are acting to keep down on this, because direct light on it all the time from, or direct radiation all the time from the sun would actually cause it to get pretty warm. 40 million total person hours have spent building Webb's 14 countries. 29 U.S. states and Washington, D.C. have contributed to it. These are just interesting facts about it. The sun shield, and this is really cool, the sun shield that's protecting Webb is equivalent to an SPF factor of 1,000,000. That's how much sun protection it gives the observatory. And that's what Webb is. It's a telescope, and that's how it's going to be referred to, but it's an observatory. It is a space observatory. Out there, it could be repositioned to do a bunch of stuff the same way that observatories on Earth can do, except it's not dealing with refraction of light in Earth's atmosphere. Two different things protecting light from instrumentation, so you get that deeper, darker, non-light polluted picture. It's going to look back in time like 13.5 billion years. It's a few 100 million years after the Big Bang, and that might seem like a lot of years, but in terms of 13.5 billion years and a few 100 million years, it's a relatively small amount of time. It's so sensitive, and I love this bottom left thing. So sensitive to heat. It could pick up a bumblebee at the distance of the moon. So it could pick up a bumblebee on the surface of the moon. That's crazy. If it was on Earth and pointing at the moon, it could see a bumblebee flying around. That's how sensitive the instrumentation is. So, the rest of the stuff in this is really cool. If you'd like this document, it's in the Webb Media Kit. I'm going to post the link in chat because it's a cool doc to move through. There's international contributors are all over the U.S., in Europe, some of them out in partners that work out in the Pacific. But it'll switch to its internal power about 15 minutes before launch. It'll jettison its solid boosters. It'll get rid of its fairing. The first stage will set. This S2 will light. The launch vehicle will separate. It'll start doing a series of rolling maneuvers. And at 33 minutes after launch, which is probably where we'll cut it, we're going to make sure those solar arrays deploy and that it's on its way to where it's going and it has its ability to generate its own power. It's going to make some course corrections along the way. There's one more graphic I'm trying to get to here. This one. So, the major deployments. It's going to deploy its solar arrays this morning. It's going to deploy its communications systems within the day. And then it's going to head out to this L2 point, deploying its sun shield, deploying its mirrors. So, in about a month, we hope that we'll hear a series of good checks from NASA, ESA, and the CSA saying Webb is checked out. We've reached this major milestone, and that the mirrors are deployed, and we've gone into calibration, instrumentation's ready to go, and we start going, wow. And start seeing some of this stuff that's going to be very different than what you're used to seeing from Hubble. And I'm very, very excited to see what the first things that we decided to look at with Webb when it gets out there. So we're going to bring the webcast from NASA back up.
After launch, this facility will command and control Webb for the duration of the mission. We'll be looking at the mock at key moments throughout the broadcast, and this will become a familiar location.
I am going to move. Apparently, they're going to picture down at the bottom here. I am going to move all my stuff.
So as we move closer
away
to
from
launch,
where it's at,
we'll actually keep a picture of the launch facility right here on the screen. But for the next 10 minutes or so, we're going to talk about some of Webb's principal science goals. If you've ever seen a telescope before, I'm certain it didn't look like this.
Nope.
Of course, the look of this particular machine is a direct result of the scientific questions it's been built to pursue. So fortunately, we've got an expert pair of guests with me this morning to help explain those science goals and much more. So I'm joined now on the set by NASA's Deputy Project Scientist for Exoplanet Science, Nicole Colon, and also with Macarena Garcia-Marin, the Instrument and Calibration Scientist for Webb's Mirroring Instrument from the European Space Agency. So welcome to you both.
Thank you. Good
Thank
morning.
you.
So this is our chance to kind of step back and talk about the science goals of Webb. You know, this is the part that really excites astronomers like all of us. And I know that there's unusual things about it being an infrared telescope. There are specific science goals, infrared answers. So maybe you could start us out, Nicole, with you're an expert on exoplanets. How is the infrared really important for your study?
Sure. Well, with exoplanets, we want to study their atmospheres. And as a reminder, exoplanets are planets that orbit distant stars. So we're looking for very small signals when we study their atmospheres. And
Warning
Webb
case.
is this giant telescope that we're able to use to collect these small signals and look for infrared signatures, chemical signatures of water and methane and carbon dioxide, those types of molecules in their atmospheres. And why the infrared? You know, that's really because those signatures are the strongest in the infrared. We know that they exist there, and so that's why we want to use Webb to look there.
It seems an amazing idea. So
Very basic
exoplanets,
explanation,
planets
but
around other
yes.
stars are light years away from us, tremendously distant. So how do we know if it's water, methane? I mean, how can we probe an atmosphere so far away?
Well, with Webb, there's a couple different ways, but one of the main ways is actually using the transit technique. And this is an indirect method where we actually detect the decrease in starlight that happens as a planet goes in front of its star. But then imagine the planet has an atmosphere. Well, there's an additional decrease in the starlight.
One good one. Welcome in. So what's being described here is a transit technique where a planetary body passes in front of its star. And that's actually how we detect exoplanets right now with, Hubble and other instruments.
In this case, Webb.
So going from, the relatively nearby stars and planets,
Zeb,
you're an
welcome in.
expert on very distant things, distant galaxies. So how does infrared contribute to your field of study?
So with Webb, we're going to be able to observe the very first galaxies and stars. We're talking about 3.5 billion years ago, so it's really mind-blowing if you think about it. And why infrared? Well, those galaxies emitted their visible light many, many millions of years ago, and that light travels towards us in time, and at the same time, the universe expands.
The
So in that
visible light
process of
spectrum from
travel
things
and
that happened,
expansion,
that
the
many
light
billions
shifted
of
from
years
the
ago
visible to the
doesn't
infrared.
have
And so
the
Webb will be
greatest
able to
chance
actually
to make it
observe those
to
very
us, especially to Hubble.
original primeval
because
galaxies. And not only those, but it will also allow us to
Visible
observe
light
everything
wavelengths don't
else.
travel
So we
as
can
far as
observe
fast as
the
infrared light
visible
wavelengths do.
galaxies from the first ones to the ones we see today.
This is something kind of amazing. So our eyes interpret different energies of light as different colors. And infrared light is a color that our eyes are not.
I would
sensitive
sit in this
to.
lady's
So like you
astronomy
said,
class
it's actually
forever.
just the
I could
space
listen to her
universe
talk about
stretching
this
out
forever.
light and changing it from visible light into infrared.
Into infrared, exactly.
So how are these first galaxies different from galaxies today?
Well, when you look at the images we have of the oldest galaxies we've seen, they look like fluffier and clumpier. We know they have a lot of star formation, so that they are actually, that's a really good signature to measure them. And they are like little seeds that afterwards they merged and got together and evolved until the ones we see today, which are like spirals and elliptical galaxies.
So from the near universe to the far, one of the things that infrared is very good is seeing through dust.
Yes.
It's another huge advantage. Maybe Nicole, could you sort of take us through that story?
Sure.
I feel like these two are
with
defending their
just-
PhDs
there's,
to
well,
the
first there's
professor
all the
here.
gas in
It's
the
actually
universe,
interesting.
But how stars and planets form in the first place, they are forming in these very dense clouds of gas and dust that come together, and it's very difficult to see through them with normal visible light. And so the infrared is actually able to see through that, almost like an X-ray, sees your bones, sees through our skin. You can use the telescope like Webb to see through the dust and see the inner stars forming, or see some newly formed planets that are also very warm from having just formed.
Yes, that right there is the difference in a very mundane sense. How they faded all that stellar dust out of there, and we're able to see through it like an X-ray. It's a great analogy because that's what you're going to do.
Right around the time of the very first galaxies, even before that. And so we'll be able to measure them, maybe not the very first one, but the first population of stars, which is really interesting because they were formed out of a very pristine material. And then from there, they evolved into more evolved stars that created all the elements we know today, things like gold, platinum, carbon, everything. Us were formed out of those original stars. So it's a really it's a really amazing adventure to observe all these objects and understand them better.
You know, there's so many wonders in the universe, and one of the things that I would never have believed was real unless I'd seen it, the data with my own eyes, is the TRAPPIST-1 system. And that this is actually going to be one of the targets for Webb, is that right? Tell us a little bit about TRAPPIST.
Sure. TRAPPIST-1 is, like you said, it's going to be a target. There are 7 planets in the system, and they're all small, around the size of Earth, actually. So it's also a very compact system. So it's not just that there's a lot of planets and that Webb's going to observe every single one of them, but it's the compact nature that's just really fascinating, because the entire orbit of the planetary systems, like all 7 planets, they fit inside our orbit of Mercury around the sun. And Mercury is our closest planet to the sun. So imagine 7 planets in there, and there's a lot going on, but it's very exciting because we'll get to learn and do comparative science and see, are all these planets...
TRAPPIST-1 is indicative of a planetary system that's much younger than ours, because of all of the stellar objects' distance from its star. Now, that's also, you can't make the assumption that the density of TRAPPIST-1, which is the star, is the same as our star, which would exert different gravity. But the idea that the planetary bodies are so close to TRAPPIST-1 is an indication that the solar system, the TRAPPIST-1 solar system, is much younger than ours.
Inevitably run into unexpected challenges. Along the way, just like any of us, it encountered things like snowstorms in the east, wildfires in California, hurricanes that...
So we're 1 hour and 2 minutes from Webb launch. I'm keeping my eye on what's coming out of French Guiana as well, and everything still looks good. As was stated at the kickoff of the webcast, weather's the concern this morning. Morning, Rocket. Merry Christmas to those of you coming in. Very odd to be streaming a space stream on Christmas morning.
While the team rushed to finish cryogenic testing on the primary mirror segments using power from diesel generators. Engineers had to endure a large snowstorm, known locally as Snowmageddon, while testing the Integrated Science Instrument Module at the Goddard Space Flight Center. And of course, everyone has had to contend with the global pandemic. One particularly memorable challenge was working through Hurricane Harvey in 2017. This massive cyclone dumped 40 to 60 inches of...
I remember that, and checking in on Sparky and making sure everyone was okay.
Causing catastrophic flooding and $125 billion of damage, all while the telescope was undergoing cryogenic testing at NASA's Johnson Space Center.
Now you've got about an hour, Rocket. We're just learning about it right now. And I'm leaning heavily on NASA this morning because I woke up at 5:15, and I've read the material, but no one's going to speak better to this than the scientists.
It was rough, to say the least, but the team...
Speaking of that, AB Emblem posted very late last night that NASA had released the patch for this mission, and I'm going to bring that patch over here real quick. The patch is beautiful. Mission patch for Webb is beautiful. I grabbed one, and according to Manny, he got the last one last night, but it will not be the only time they stock the patch. That was just the initial space nerds going nuts last night, because it posted at like 10, and by midnight they were gone. If you're interested in this patch, this is one of those things that if you have a wall of these things like I do and Manny does, and now J-Mitch has started one, this is one that's going to be a mission for a long time. It's like Perseverance was. It'd be worth having if you're interested in space patch collector at all.
John is Webb's senior project scientist, and we're so pleased to have you here today, John.
Good to be here with you, Michelle.
So to start this incredible story of Webb, let's start with something that's deceptively simple: gravity. There's something special about gravity.
Gravity is special. Gravity always pulls. It's the only force of nature that always pulls. So that's special. And what makes that special is that gravity, although it's very weak, is very long range. It can reach across the universe and slow down the expansion of the material that came from the Big Bang, turn it around, pull it back together.
Yes, Drac. It can shed light on our understanding of places. Like we have planets out there that we believe are what we call planets in the Goldilocks zone. Planets that exist in a position relative to their individual stars that we believe are potential. They have the potential for supporting a carbon-based life structure, right? It's called the Goldilocks zone. It's just right, right?
Which is not
So
something other forces can
Webb
do
will give
all by
us more
themselves.
on that
Lots of
because
gas
we've
will
just
be
been observing
compressed
positions.
by the gravity
We can
and
tell
slowly
that there
get
is
heated
a
up
stellar body
hot enough
there
to
that
light
is
up
a
and have
solid
nuclear
mass that
reactions inside that
can
turn hydrogen and helium
maybe
into the
probably
chemical
support
elements
life
you see
because of
around
where
you.
it is relative to
Here in
its
the
star.
house, here on the set.
But what Webb can
So
let us do,
carbon,
it's a
oxygen,
very, very
everything
excellent
we
point,
have
is
think of as
back to
ordinary
the idea of
from inside
detecting
stars. So we
the
are stardust as carbon
within the
source.
spectrum
There
bands
wasn't any stardust
of
in
the
Big Bang.
atmospheres
So we
of
need
these
to start
stellar
with the story
bodies
to be
is
figured
there
out how do
water,
we
right?
come
Because
to be
again,
able to
basing
live here
ourselves off the
on our little planet
assumption that
when the universe started out without
that
all of
life
these
is going to be
things.
based off of
So you
elements in
mentioned these
that
planets
middle
around the
column and
stars. So
of
we're
I can
almost
either
sort of
take
going through
or
all these
give
amazing
4
science
electrons.
levels of the Webb.
In
What about
chemistry,
what can you
carbon,
tell us
silicon,
about
all that
planets
down that
on
line.
other stars?
It's going to
Well,
work
once
off
in
the
a
same
while, a
idea that
planet goes in
if
front
it's
of the sun,
biologic
and so the
life, it's
starlight
going to
goes
need
through the
probably
atmosphere of
water
the
to
planet, which
survive.
has
You
an
know,
atmosphere on its way to the
it's a
telescope.
it's a
We
great
project
it's a
that
big
light
assumption too
into
because
a
we're
spectrum,
assuming that
or
life is
what we
life
would call a
everywhere and has the
rainbow.
same basic ideas.
We'll
But on
analyze
that
also what are
assumption,
the chemicals that are
Webb
in
is
that
going to
atmosphere.
let us
So we will
see
be
if
able
those
to tell you
Goldilocks zone planets
maybe
that we're already
just
aware
wondering,
of
whether those little planets
have water,
that might be like
have
Earth
atmospheres that can
actually could
support
have
life. So
traces
yeah, it's
of
an
water in that
amazing,
atmosphere,
amazingly
maybe
good
enough
point,
water
Drac.
so there could be a liquid
And
ocean under that atmosphere. One of the great questions.
it's
So we know they're
it's
planets.
something that Hubble
We
can't
know
do.
when we should look. We just don't know what we're going to see.
So after the Webb launches, one of my dreams is I'm going to be standing outside in my backyard and point to a star and say there's a planet around that star that we know has water vapor, oxygen, perhaps methane, carbon dioxide. So what is Webb going to also do in the search for life closer to home, our own backyard?
Well, here in our own solar system, we will be looking at everything from Mars on outwards to the farthest we can see. Satellites, comets, asteroids, and the planets themselves. And some of them are really interesting and special because we know they're possible homes of life. What would make a thing a home of life? Well, if it's wet. That's the good clue. So the satellite Europa, which orbits around Jupiter, was discovered by Galileo himself. And we know now that it has an ocean that's covered with ice. There are cracks in the ice where water comes spitting out. NASA are going to send a probe over there to fly through those plumes. We're also going to point over there with the Webb telescope to see what can see about that atmosphere and those plumes of water.
Imagine how close we'll actually be able to look at Europa. If we can detect a bumblebee at the distance of the moon, I mean, you think we'd be able to detect something the size of a sperm whale on Europa, and that's a big leap of an analogy for me. But the idea that we might be able to actually look and see stuff within our own solar system that we haven't been seeing before, like it's insanely interesting to me.
Of that before we send the helicopter out there.
So you're on this amazing journey from the very distant early universe all the way to our own solar system. But this has also been a personal journey for you. You've been working on Webb since the very beginning of the mission. Is that correct?
I have since '95. We had our first conversation. But people were even dreaming and imagining way before that what we needed. And you could tell even before we launched the Hubble what were the possibilities. And we learned that we would need an infrared telescope that could do things that Hubble could not do.
Well, John, I've been an admirer of yours for many decades now, and it's an honor to be with you on this part of the mission. So thank you so much for joining us. Best of luck on the launch and the mission ahead.
And thank you for asking all these great questions.
The Hubble Space Telescope
that
delivered
transition is
profound
really nice.
insights about our place in the cosmos. But perhaps the biggest takeaway from Hubble is that we've only just scratched the surface. Hubble gave us the best ever views of stars and planets forming inside vast, dark clouds of dust. But as soon as we had that data, we were asking new questions that...
By the way, this is what's missing from a SpaceX presentation of look at how awesome SpaceX is. The fact that they're talking science and have been talking science for 25 minutes is awesome.
These distant galaxies are just tiny dots in Hubble's images. Tantalizing.
Welcome back, Fish. Glad you caught that.
In order to pursue a better understanding about the earliest days of the universe, we needed to build a better time machine, and that's Webb. So I'm going to be rejoined here by Nicole and Macarena, and this is our chance to talk a bit about building that better time machine. What about the technology of Webb? So there's so many aspects of Webb to start off with, but maybe again, going back to the theme of infrared. The design of this telescope is so different because we had to use infrared light, heat light. So tell us about some of the challenges of, for example, why does it have to be so cool? Tell us about infrared light in the design.
Right. Well, I think we've heard already just how cool it has to be. It's around or below 50 Kelvin, and that's minus 370 degrees Fahrenheit. Actually, below that is what it operates at. And that's very cold. And the reason we need it so cool is because we don't want the telescope itself to detect itself. Because there's several instruments on board. There's and there's some
CSA is reporting that the Ariane 5 rocket is fueled. Launch still scheduled for 7:20 a.m. I'm going to bring over a picture of it on the pad for you guys.
So you just don't want to detect.
This is the launch vehicle this morning.
Macarena, you are the instrument calibration scientist for the coolest instrument.
It is the coolest
on Webb.
instrument, yes.
Miri. So tell us a bit about Miri and why it needs to be so cold.
So Miri, it's a really unique instrument, and it's a great example of this collaboration we have in this mission because it's half European, half US.
I'm actually going to bring this back out so we can see the subtitles better here.
That uses the mid-infrared light.
And I'll reload this when they transition, so we're back to live.
Rather a bit cooler than the near-infrared light, and so because of that, Miri needs to be colder in order to detect that very faint signal.
At multiple NASA, CSA, everyone reporting.
So
Vehicle is fueled. Launch still scheduled for no earlier than 7:20. It's important to note this morning that the launch window is a 30-minute window, so it's not an instantaneous launch. They can suffer a little bit of a slip if they need to, but no later than 7:50 a.m. Eastern Time.
A few degrees above the absolute zero.
And we were talking about you don't want the telescope to be so hot that it's basically giving off its own signal, its own radiation, and that leads us to why it needs to be in space, right? So tell us a bit about why do we need to launch this thing into space to see these?
That's actually an amazingly good point too. That its own heat signature can interfere with its observing capability, and that's why they want this thing to be in space, and that's why everything has to be cooled off before they use it.
The wavelengths that we want to observe some of these stars and planets and galaxies. Those wavelengths are actually where Earth's atmosphere is opaque. So with telescopes located on Earth, even at higher mountains where they try to get above the clouds or atmosphere sometimes, there's still residual atmosphere that we're trying to look through and peer through. So in order to see the full infrared wavelength range at a very high sensitivity as well, we need to go to space.
Absolutely. So we talked a bit about some of the power of techniques like spectroscopy. We've heard Dr. John Mather talk about it. So let's go a little bit more into the details of how spectroscopy works and why it's so powerful.
Oh, sure, yeah, I can keep going. Well, with spectroscopy, we heard, so visible light, again, is kind of, it's a rainbow of colors that we don't see naturally. But if you use something like a prism, you can separate out that light and see all the colors from, blue to red. But then the infrared is redder than the human eyes can see. But you can still do the same technique where you have spectroscopy tools or instruments like Webb has, all these spectroscopic tools, so that we can break up the infrared light and look at certain colors, if you will, so that we can see certain
pieces of infrared.
Whether it's
imagine the invisible red light that is infrared was taken into its component pieces and split into its shades per se. It's not visible, but that's what a spectrograph does, and allows them to see, like that image that showed before, the different microns, the different individual pieces of that IR signature, and break it apart. That's what a spectrograph does.
It simulates an eclipse. So when we have a very bright star with planets around, for instance, usually when you take an image,
I'm trying to dumb down some of it, but I'm probably failing at that drastically. Because my understanding of spectrography is more from microwave.
It's really a technique that's going to be very much used and to do, like in this image, direct imaging of planets.
Well, thank you so much. We'll be back to talk to you more with some social media questions. Thank you very much.
Thank you.
NASA and its partners began developing the Webb telescope years ago, growing from an initial inspiration to a design, then schematics, and finally reality. What started as a big dream of studying the origins of the universe required best-in-class engineering expertise to transform into something real. Let's take a short look at the very
You can tell she is used to speaking to a big audience. I want to know where she. I'd love to sit in those classes.
Were already discussing what should come next. Ideas for what was then called the Next Generation Space Telescope evolved throughout the 1990s, and by the end of the decade, NASA had a preliminary plan. Construction of the James Webb Space Telescope began in 2004. Beryllium was mined to create the mirror segments, which technicians polished and coated in a thin layer of gold. Meanwhile, engineers designed and built new science instruments in the US, Europe, and Canada. Every step of the way, there were reviews and tests to make sure each part could withstand the rigors of spaceflight. By the early 2010s, the team began bringing individual components together at NASA's Goddard Space Flight Center in Greenbelt, Maryland. It was there that the mirrors and instruments began to coalesce into the grand machine we see today.
We've said before that the James Webb Space Telescope is an incredibly ambitious mission. Big ambitions come with big challenges.
What up, Manny? Good morning.
From the beginning,
Merry Christmas,
the
my
design
friend.
of this observatory has been a balance between the boldest questions scientists have dared to ask and the cutting-edge technology that our best engineers could offer.
Thanks for hanging out this morning for those of you that are
Remember
here.
to clonk that follow button.
Don't forget to do that.
Could be. Another example of the delicate
I know it's
balance
Christmas.
between desire
I know
versus
that's a weird morning to do this on, but
not only of the mission's
this
goals,
is when they're
but the
doing it,
mechanical guts of
and
the observatory itself.
Perseverance was a big deal. This is a bigger deal.
My lord. Telescope better than just about anyone. I'm here with Keith Parrish, a senior engineer on the Webb mission. And Keith, you brought something to show us today.
Yeah, yes, I did. So conceptually, Webb Sunshield is actually quite simple. All we need is 5 tennis court size pieces of this material outstretched to protect the telescope from the sun. So what I have here is an actual sample of that material. This is just Kapton.
It's so light, yeah.
Yeah, it's an industrial, you can buy this, and it's commonly used. And what we do is we buy it for Webb. We seam it all together in small pieces, and then we actually
just 5 tennis court size pieces of Kapton, which they've been using since Mercury.
Purplish kind of hue to it, and the reason it's
The idea that you can just go buy it now is insane, by the way.
And we actually put.
All right, Fish, there will be a VOD. If you swing back around when you're done, we'll be happy to have you back. But Merry Christmas, and thanks for hanging out.
What it does is it gives us a nice electrical conductivity. We don't want any surface charging building up. And the other thing is
that's one of the big things here. Is like gold's involved, beryllium's involved, Kapton's involved. These are all materials that did not support ionization.
For many years in space.
And then this whole thing has to unfold somehow. Where we can actually see that behind us.
Exactly right. So if you're looking at animation there, unfolding there, so it's actually S-folded up, almost like a fan.
That's cool.
We call it S-folding. And once we get it all folded up, we secure it to a structure by actually pinning it for launch. So, huge shout out to our mechanical engineer and our entire Sunshield team, because they've come up with some really clever ways to secure this for launch, unfold it, fold it, and then, ultimately get it safely deployed in orbit.
That's wonderful. So speaking of unfolding and all these pins that need to release, let's go over here and talk to James Cooper. You're going to show us what's going on there.
This is awesome.
Hi. So I have here an example of a non-explosive actuator. We have 178 of these.
These are all these little pins we're talking about, right?
James Webb, right?
Yeah.
107 of the 178 are the membrane release devices. And we use this type of actuator because it produces a very low shock when it's released.
Yes, there's no force exerted on the craft.
The animation shows conceptually how it works. We send an electrical signal through either one of our connectors. We use both.
There's 178 of those wired on this thing for the simple purpose of releasing a pin to allow the sun shield to unfold. That's crazy.
Halves of a split nut to separate, and then our pin can get extracted. And so in the case of the MRDs, it's a spring-loaded pin that pulls to release the folded membranes. In other places, we would be bolting 2 pieces of structure together.
Kapton is very easy to tear. You could actually, well, it's not easy. It's kind of like a phone book, Rocket, if you tear it the right way. If you try to punch Kapton with your fist, it's not going to rip. If you get in there and you...
various configurations around the entire observatory.
Right. Well,
the membrane itself of Kapton is a good word, is actually compromised. It's easy to tear. Like, it's kind of like once you get it started, it's easy to tear. But if it's kept intact, if its integrity is good, Kapton's very strong.
One of the 18 mirror segments on James Webb. The real ones would be machined out of a single piece of beryllium to the exact curvature we need. And then once we're deployed on orbit,
that is the size of one of the 18 mirror segments.
it act as a single perfect mirror.
Now that coating, tell us about this gold coating here.
Yeah, so this is coated with a very thin layer of gold. It's only a few hundred atoms thick of gold, and that gold is really good because it gives us a reflective property in the infrared, and that's really what Webb is an infrared telescope, and we need that sun shield exists to cool this entire telescope. So this mirror actually runs about minus 400 degrees Fahrenheit on orbit. If it were warmer than that, the infrared energy coming off of this, that heat energy would
I'm pretty
swamp
sure
our detector system in our instruments. So that entire sun shield exists to cool all 18 of these down. And again, this gold coating is what helps with all that reflectivity to make it perform even better.
So for those of you that aren't familiar with the way that this type of thing works is there's a mirror here, right? There's a mirror here and there's a piece that sticks out here. Everything comes in, bounces off the mirror, and then toward that collection point that sits out for satellite communications. It's called Cascadian feed, where it would hit that and then feed back through the tube. But it's a parabolic receiver, so everything on the Webb is kind of curved so that as things hit it at different angles, it all gets collected back at this point that sits out in front of it, and that's where the actual data or the visible readings are being taken. Not on the surface of the curved mirror, but at the point that it's all being bounced back to and collected and focused at. And so gold's great for that because as was stated, it's going to reflect IR really well. And then it's also not going to be it's not going to be ionized very easily.
And then ultimately it all folds up and gets stowed into this structure for launch.
Right, so the membrane release devices would be along the back side of these structures on the forward and the aft side. And we release them in rows so that we can sequentially start to unfold the membrane once those pins are pulled out.
Also, don't forget that
that's wonderful. Thank you so much.
If you've saved the NASA Eyes app, you have it on your desktop, or you have the NASA Eyes website, you'll be able to track where Webb's going to be on its journey all the time.
Okay, let's get a live launch status update from NASA commentator Rob Navius at the launch site. Rob, how are things in Kourou?
Well, thank you, Michelle, and Merry Christmas from the Jupiter Control Center here in Kourou, French Guiana. You are looking live at an Ariane 5 rocket on its launch pad, ready to send the James Webb Space Telescope on the initial phase of its journey. The fueling of the Ariane 5's first and upper stages began before sunrise, and in the last few minutes, mission controllers here in Kourou and at the telescope's control center at the Space Telescope Science Institute in Baltimore conducted polls with all positions.
The Space Science Institute in Baltimore is where the mission will be managed throughout its entire life.
Monitoring weather conditions throughout the night, keeping tabs on clouds and wind speeds.
I do love the fact that there are controllers sitting there with Santa hats on. That's great.
Precise commit criteria are acceptable.
I hope so too, Drac. And throw it on mute. You got 40 minutes. Seeing the launch is probably the coolest part of this show, but feel better quickly.
The flight control team here in Kourou. By the way, our broadcast today is a collaborative effort between NASA and the European Space Agency. So that's it from now. From the Ariane 5 Mission Control here in Kourou. We'll be back with you soon. For now, let's go back to the Goddard Space Flight Center and Michelle Thumb.
So I'm going to stand up real quick, walk around. I'll be listening.
So Webb asks big science questions.
Leave this running because this is what we're here for this morning.
It inspires
I'll be right back.
And excites people to dream and wonder. And the spark of inspiration is the ignition of creativity. Kids all over the world have a natural affinity for Webb's big pursuits. And now we have a collection of young artists ready to showcase their work.
Hi everyone, I'm Kelly Girardi, and this is Delta V, and we're kicking off the Unfold the Universe Challenge with NASA and the James Webb Space Telescope. NASA is hosting an Unfolds the Universe Art Challenge. Use your imagination to share what you believe the Webb Telescope will find.
I believe that the Webb Telescope will see galaxies, stars, planets, the moon, and don't forget our star, the sun. in the sky, really high. It's space.
Ooh, space. Thanks, Greta. Good job.
This is my picture of space. Hello, my name is Gabriel. I am from Romania. This is how I imagine space. Hello everyone, good morning. This is a drawing of distant galaxy that can be seen by James Webb Space Telescope. Hi, my name is Anastasia, and this is what I drew, what I think the telescope will look like, what the telescope will see. I drew the Earth, the Sun, a new planet, a black hole, and stars.
That's great.
So we've been fielding social media questions from viewers all over the world this morning, and let's take a couple of minutes to share some responses. There's been a couple questions about how long will it take for images to come out, and there's a lot of things that need to happen before the images are coming. So Macarena, why don't you take us through some of that?
Yes, so for the first scientific beautiful images to share with the public, that will take 6 months. And the reason is because it is, so we launched today, it takes a month to take to the orbit place, to the Lagrange 2 point, and then we have a whole period of cooling down the instruments, aligning the mirrors, and making sure that all the instruments are ready to do science. So the whole process takes 6 months, half a year.
And also all of those 18 segments of mirrors, something needs to happen to get them all working together too, right?
Exactly, because initially you launch with 18 segments and they work separately. So you will take, if you observe one star, you will get 18 little points. So
they have to create an array.
A process where you take images with NIRCam, which is one of the cameras on board, start moving the mirrors slightly to make them work as a single one, and they, by the end of this iterative process,
They're basically talking about array alignment, where after launch, obviously there's going to be shake, right? These things aren't going to be correctly positioned. The segments have to be calibrated. That's part of that instrument calibration phase.
Will Webb be able to enhance detection of comets, asteroids, or meteors that enter our solar system? So that seems we've got a planetary person here.
Sure. Yeah, well, Webb does have a special observing mode where it's able to track these rapidly moving objects, because compared to these distant stars and galaxies, asteroids and comets, they move pretty quickly.
Yeah, they're like
and
F1
so
cars.
We're able to do this so that we can study material that's outgassing from them and learn more about what they're making.
That's actually pretty cool to see the outgas material spectrum of something like coming off a comet trail.
From Kristen Rodriguez on Facebook. How long will it take James Webb to reach Lagrange point 2?
1 month.
You might also just explain what is Lagrange point 2?
So it takes a month. I think it's actually 29 days to get there. And the Lagrange 2 point is this very interesting stable point. So the gravitational pull between the sun and the Earth create this point where it is stable, and you can, as we can see there, Webb can orbit around the L2 point in a very stable orbit, only needs a little bit of corrections once in a while, and it can always have the sun shield protecting the telescope from the radiation of the sun. In a year,
that's the best drawing I've seen so far of that explanation.
The sky, and it's a continuous observation.
Well, thank you very much. We'll hopefully come back to a few more questions later. Thank you. So this is a big mission with a cast of thousands to bring it to life all over the world.
T-minus 35 minutes to launch.
Take a brief look at the main locations.
Again, at T-minus 15, Webb will go and the vehicle will go on its internal power.
Inside the massive high bay clean room at NASA's Goddard Space Flight Center, engineers assembled the 18 gold-covered mirror segments into the backplane of the telescope. And
I am really excited. Welcome in, her. Good morning.
Contributed by international partners. To simulate the harsh environment of launch, they went through vibration tests and acoustic tests. And to simulate a space environment, the instruments endured cryogenic
Doing well.
testing
Merry
in a
Christmas.
large thermal vacuum chamber. But it wasn't large enough.
I woke up like a shotgun this morning when my alarm went off. I was like, oh, this James Webb's day. I'm going. Let's go.
Chamber in the world big enough to fit the entire assembly. Chamber A at the Johnson Space Center was originally built to test the Apollo spacecraft, and half a century later, it provided a grueling 100-day test for the Webb telescope. Next, the telescope traveled to Northrop Grumman's facilities in Redondo Beach, California to meet up with its other half, the Sunshield and spacecraft bus. Fully assembled at last, the entire observatory went through yet more tests. Many focused on making sure the spacecraft could properly fold up for launch and unfold in space. Then in September 2021, Webb caught a ride on a specialized cargo ship and set out on a 16-day voyage to the European Space Agency's spaceport in Kourou, French Guiana. According to its travel itinerary, that's Webb's last port of call on Earth.
Once Webb gets into space, we're going to have some exciting things to tell you about what happens next, from its extraordinary engineering to the thrilling scientific adventure.
Imagine in about 6 months that
And for that, I'm going to turn it over to Katie Haswell, our host at the launch
the
site.
NASA astronomy picture of the day, which has largely been dominated by Hubble for the past, several decades, start seeing Webb images popping there, and then they're going to have to be explained to people because they're not going to be what we would see if we look with our eyes.
Well, it's all looking
It's going to be
very good
super
here
interesting.
at the spaceport
Second half
for
of
a Christmas
2022
Day
from a space
launch.
observations.
Operations running smoothly, the countdown ticking over nicely. All the systems are green, and we are go for launch.
Vehicle is fueled, has been fueled for a while.
Launch pad number 3, the James Webb Space Telescope.
Look at all those flags on the boosters, man.
In first class.
On the the secondary boosters on this craft. All those nations.
In about 32 minutes time.
It's a great allegory on Christmas Day to how much humanity can do when they put the crap to the side.
About 10 kilometers from that pad, and behind me you can see it's a laser focus here in the control center.
That's the most populated I've seen the gallery in Kourou as well, ever.
Closer to launch. We call this the fishbowl behind this protected glass. And up in their skybox here in Mission Control are NASA's Rob Navius and the European Space Agency's Luce Fabregat, and they're standing by to take over the commentary about 15 minutes as we get closer to launch. First of all, though, let's check in on the countdown and let's see how things are progressing with Stefan Israel. Stefan is the CEO of Arianne Space. Arianne Space is the company responsible
the CEO should be talking
for getting our telescope into space today. Stefan, thanks for joining us. No pressure.
Good morning, Katie.
How are things looking?
So we are now 31 minutes before liftoff. So far, so good. Ariane 5 is ready. Webb is ready. The range is ready. And the weather.
Those of you that may be curious, the Ariane 5 has no reusable components. It is a fire, and that's done rocket. The Ariane 6, which will replace it, also doesn't have any reusable components, which is a big miss by Ariane. But I do want that dude's pin, that Webb mirror pin. That thing's awesome.
Humanity this morning from the Guyana Space Center. You know what Webb is about? After Webb, we will never see the skies in quite the same way.
It's an important project, isn't it, for everybody?
It's a very special mission, but we have delivered already 100.
This is probably the most significant space mission, apart from getting people back on the moon, to me.
In the control center, cool, calm, and collected.
Kind of like we talked, I mentioned the other day Parker Solar Probe and how it pierced the sun's corona and sent back images from basically inside the sun's atmosphere, and how amazing that is. This is up there with that.
Which is the authority that takes all the final decisions in the event of unplanned situations. Now, we are in French Guiana. We're on the northeastern coast of South America. We're in Amazonia. It's hot. It can get a little bit sweaty sometimes, and there are lots and lots of mosquitoes. But somebody who knows it very, very well is Raphael Chevrier. Raphael is a rocket scientist, or a rocket expert at least, from Ariane Space. Thanks for joining us, Raphael. Tell us a little bit more about French Guiana.
Well, French Guiana is a French territory that borders Brazil. It's located in the Amazon rainforest. 97% of the land is covered in trees, so that's why it's so green and beautiful.
That is a lot of trees.
You can totally imagine that the wildlife there is absolutely incredible.
97%.
One of the best preserved habitats in the world.
And of course, it is in the jungle, and yet it is actually the European spaceport. So what makes this location in South America so important?
Close to the equator?
Well, there are several reasons for this. First, we are on the coast. It means that we can launch over the sea from north to east without having to fly over inhabited area. So this is very convenient to reach any kind of orbit. There is no hurricane here, big tropical storm, there is no earthquake, but more importantly, we are very close to the equator. so that we can benefit from what we call the slingshot effect given by the rotation of the Earth. So let me take this globe. Basically, here on the equator, we are all traveling at roughly 1,000 miles per hour. That's very convenient. Of course, we don't feel it. If we were on the poles, that speed would be very, very close to zero. It means that when Webb is right now on the launch pad, inside the
it's already going close to 1,000 miles per hour.
Traveling in the right direction, and we can
you don't have to gain that. They would not have to, a polar launch would have to gain that 1,000 miles per hour first, which would be an extra propellant.
And increase its operational life in orbit at 1.5 million kilometers from here.
And that really is important.
It's a great explanation of it. I need a globe. I need a globe to sit here and make that same explanation every time someone rolls in and asks that question during a space stream.
That's exactly what Webb needs, isn't it?
Yeah, that's very convenient for Webb. It's also located in a nature reserve. So this is the perfect meeting between nature and technology, and people come from all over the world to work here. But one thing that's been very important for Webb is cleanliness. Because you know that one speck of dust could alter the vision of the observatory in space. That's why we have been extremely careful in keeping a pristine environment in all our...
How are they going to handle if dust gets on the mirror when it's in orbit?
So let's talk a little bit now about the Webb Space Telescope. I really don't think you need me to tell you.
And I don't think that question has really been answered adequately so far.
Of human ingenuity. And you don't get to make a telescope as complex as the James Webb Telescope and as remarkable without tremendous amount of collaboration. And the James Webb Space Telescope is indeed the product of a partnership between 3 space agencies who came together to create it, NASA, the European Space Agency, and also the Canadian Space Agency. So here to talk about that now is Greg Robinson from NASA. Greg, thank you very much for coming to the floor, out of the fishbowl as well for us. And we're talking serious teamwork here, aren't we?
Yes, Katie. We've benefited from an amazing partnership with the Canadian Space Agency and the European Space Agency. Over the life of the development, we've had more than 10,000 people actually touch Webb, 29 states in the U.S. and 14 countries across the globe. And not to mention the amazing industrial base across the globe that have benefited here. In order to do bold missions like this, it takes lots of resources and lots of expertise, so we maximize everyone's expertise.
And how did this bold mission get onto an Ariane 5 European launcher?
So as part of the partnership, the Canadian Space Agency contributed science instruments, and they're incredibly important for this mission. And so did ESA, science instruments, and the amazing Ariane 5 that we will see take us on this.
I'm still curious as why it was not ULA.
We're looking forward to that.
I mean, the Atlas certainly can put this thing in orbit. It's sent things further out. It can carry the mass for sure.
I wonder how you must be feeling, Greg.
I mean, maybe was part of the deal to use an Ariane 5, but
telescope is sitting there on top of the rocket, getting closer to launch.
I never heard of a process where like there was a bid where ULA was involved, and they probably are the. I mean, SpaceX didn't have the ability to launch it on a Falcon Heavy probably at the time they were discussing the specifics of it.
Start flying a lot.
Well,
but it is curious to me that it's always been Ariane, and I don't mind that. An Ariane 5 is a reliable launch rocket, but ULA has like a 100% mission success for these big missions for NASA.
Greg Robinson, thank you very much indeed.
But that's also because ULA slips their launches, you know, like they're on an ice rink.
The Ariane 5 launch vehicle is the heaviest lifter in the Ariane 5 Ariane family of launchers. And Raphael, she has got an incredible track record, hasn't she, of success?
Yeah, this is a very reliable and successful rocket. Webb is going to be the 112th Ariane 5 to be launched. And the very first Ariane, the Ariane 1, took off exactly 42 years ago. Yesterday, this was on Christmas Eve, 1979. Good symbol.
Yeah. And hopefully we're going to get a good Christmas present today as well. And I mean, the rocket is also, you don't get to build a rocket like this without collaboration either, do you?
Of course, just like Webb, actually. In fact, 12 different countries have been participating in.
That is one of the very interesting things about Arianne.
With Arianne Group now.
There's a lot of French people here, and because Arianne is a French company, but the number of European nations who work on Arianne is another one of those collaborative things where people can just put their crap down.
So first you have the two boosters, solid boosters that are located on each side of the rocket. They will provide the main thrust in order to literally push the rocket against the gravity of the Earth. Then you have these big tanks that form the main cryogenic stage with the main engine Vulcan at the bottom.
And then you have the Webb telescope right at the top, inside the fairing.
It is right there on the launch pad, and together they are put on top of the third stage, a cryogenic stage, and it is this upper stage that is going to place Webb into orbit.
And what about the engines? What are we going to see at liftoff?
At liftoff, we first see the main Vulcan engine ignite first. We do this because we want to check it's working properly before we switch on the solid boosters 7 seconds.
So the solid boosters fire 7 seconds later. Solid boosters can't be turned them off. Yeah, he just said you can't turn off an SRB. It's a Roman candle.
That's very.
It's like you light it and that's it. It's firing, which was always the big risk with the shuttle too. Is that if one of those SRBs lit, the other one didn't, it would go. It's called thermal curtain failure if that happened.
Before soaring into the sky.
So once we light the touch paper, you can count to 7 before it actually lifts off. Now, one of the advantages of the Ariane 5 vehicle is that it can be modified, and that's exactly what we've done for today's
Yep, just
launch.
like the Atlas can, just like Delta can.
For it to be able to host
Different configurations.
And joining me to talk
One of the
about
great
that
things
is
that
somebody
these
who is
agencies
the right
have that
person for the job
SpaceX really doesn't have. SpaceX launches their rockets in a specific configuration, and it's designed around the idea of recovering those spacecraft in the same way every time, but it doesn't give them flexibility.
On I-5. It fully occupies the volume of the fairing with gaps as small as 10 centimeters for a diameter of 5 meters. It is the reason why we had to develop a specific integration procedure to ensure that there is no contact with.
There's gaps as small as 10 centimeters between the fairing and the Webb telescope inside. That's real tight.
Improve in order to balance as much as possible the inside and the outside.
Remember to clonk that follow button. You turn that off. That's really loud.
Due to the fear of depressurization shock, which could damage the delicate layers of Webb Separation shield. After separation, due to the fact that Webb, some equipment of Webb are very sensitive to sun exposure, the roll control of the launcher will be tuned in order to make sure that Webb is always oriented only one face to the sun. And in addition, to avoid any hot spots, the launcher will create some oscillating.
Funny to watch the closed captioning struggle.
Like barbecue mode to avoid any overheating. And after Webb separation.
What's being talked about here, for those that are having difficulty cutting through the accent, is talking about how the craft on its way to where it's going, the L2 Lagrange point, is going to rotate to make sure that the same face is always facing the sun, so that the instrumentation on board, very sensitive to the sun, is never exposed to it.
In space, not quite all the way around like the familiar barbecue, but a slightly different movement. Listen, gentlemen, thank you very much indeed for being with us today. I know that you're busy, you've got jobs to do inside the fishbowl, so I'm going to send you right back there now, and very best wishes for the launch. Thank you.
Thank you.
Our telescope has a long journey ahead of it. It's got to travel 1 million miles to its destination in space, its working zone, where it's going to start telling us all about our universe. It's already started that journey because it's traveled.
T-minus 20 minutes to launch. T-minus 5 minutes to on internal power. First significant milestone as we count down here.
Webb was packed into a special container and transported along the LA 405 freeway, which had to be closed because it's so big.
I bet you those people were like, what the
It
heck?
traveled on a special ship. A lot of spacecraft will come to the French Guiana launch site by plane, but Webb was too big for that, so it had to travel by ship, and it went through the Panama Canal. Up through the locks. And it took 16 days to get to the port in Kourou, where it was unloaded and traveled to the spaceport. That's not the real Ariane 5, that's a model. Just outside the Jupiter Control Center, actually. It was unpacked very carefully in the facilities that Raphael was talking about. And then fueling started, and of course, the teams had to wear special suits because that's a dangerous job. And then it was
And also to keep it
all the
clean,
way
why they're wearing those suits.
of the Ariane 5 rocket. It was encapsulated inside
This
the
is great
barrel
video.
and sealed,
You don't ever get to see this process.
and then it was rolled out to the launch pad 2 days ago. From the vehicle assembly building to the pad along very special rails. Very, very slowly through the Amazon rainforest. It was raining at the time, and that was 2 days ago, and here we are now, 17 minutes and 46 seconds to launch and counting. All systems are go here at the European Spaceport.
One more
in
check in
French
here on
Guiana.
the other feeds that
We
give
have
that
3
information.
control centers on the job today. We have the mission control
256th flight of an Ariane rocket from the Ariane family, 338th launch by Ariane Space, 112th launch of an Ariane 5, the third launch of Ariane 5 in 2021. And this is what you want to see off the board at launch control at the Jupiter Space Center this morning. Everything is green.
Once it's released from the mothership, that will be about 27 minutes after launch. And they'll be controlling the Webb telescope for the rest of its life. Very important job.
Yeah. This is the thing that if you have a small kid,
James Webb Space Telescope
that as they go through
is
school
a truly
for the next
remarkable
2 decades, or at least the next decade,
People have been
going to be
working on
providing
it
images
for
back that will be discussed in
over
the
2
science
decades.
class
Some people have
and
been
then in
working on it
college
for their
classes.
whole
It's going to have an
professional
impact that's
lives.
bigger than Hubble's.
Thomas Zabrucken is the head of science at NASA, and he's joining me now just to talk about it. Thomas,
I wish they'd put his Twitter on here because Thomas Zabrucken is a great follow on Twitter.
The day has come. All these decades, all this time, all these people working on the telescope, and here we are, 16 minutes and counting to launch. It's a big day, huh?
So again, we'll take this T plus 30 today
telescope on top of this rocket.
so we can make sure solar panels have deployed. That's the only major milestone post, the big major milestone post launch today.
All the hopes and dreams of those individuals, and also tens of thousands of scientists, some of them not even born, that will benefit from these data, are there with them waiting for these last minutes of countdown for its journey to space.
I'm guessing people are feeling a combination of emotional excitement. What's going through people's minds, do you think?
Oh, I think there's
I remember when my kids were
you're on top of a rocket, many things went
barely
really well.
born
There's
when this thing
pride.
came to my
There's always
attention,
a little bit of anxiety.
and now my
We
kids are
know
finishing
launching
college
is hard.
and it is
We
being
have
launched.
one of the
That's
absolute best
that's a
teams in the
scientific
world
journey of the
this
mind, to
round.
be
I'm
sure, even for
confident in
someone
that.
who's just an
We're
enthusiast, to
super
sit there
I mean,
and
just
know this
an
thing was
amazing
being
day
built, and to
today.
check in with NASA Goddard and to see this thing's
D?
progress and the
Well, I'm a
integration and
scientist,
some of the
but for
setbacks that
me,
have occurred that have made
besides
this thing
the
slip a few years.
technology, that really is a marvel.
I cannot
It's
imagine
really
being
the
a
best we can
scientist
do.
who's wanted this
What I'm
for
thinking about
as
is
long
really
as
looking
someone
at
like
the
me
universe
has
in
just
new
been
light.
going,
We have never seen
I
the
can't
universe
wait to
how
see what it
Webb
can
will show
do.
it to us. And can you just imagine going back in time?
To have this launch on Christmas is probably the best gift I could have gotten today.
kind of just think about all the new things we're going to learn about.
Or one of them.
The most beautiful universe.
Dr. Z, thank you very, very much for joining us. And I want to wish you and all the teams.
Good.
everybody,
Glad to hear you're
the
feeling
very
better,
best
Jack.
For today's launch. Thank you.
Go Webb.
So, yes, indeed, go Webb. So we are now 14 minutes.
So
and
we should
30
be
seconds
on an internal
to
power
launch.
transfer at this
We're
point.
getting really close now. Everything's going well. All systems are green for launch. And I'm going to hand you over now.
Yeah, a lot of
to
people have built an entire
NASA's
career on
Webb
simply
makers
getting
in the
this into
skybox,
space.
alongside the European Space Agency's Luce Fabriquet, who are going to take on the commentary from here on in. Over to you guys. Rob.
Well, thank you, Katie. Merry Christmas to our worldwide audience from our broadcast booth high atop the Jupiter Control Center here in Kourou. Joining me today for this historic launch, my colleague Luce Fabriquet, the head of infrastructure and value chain for the European Space Agency. Luce, good morning.
Good morning,
Great to be
Rob.
with you. Great to be with you today.
Very pleased to be here with you and all of you watching us for this very special event.
Well, at this hour, countdown clocks are ticking backward. We are at T-minus 13 minutes, 32 seconds and counting. Out on the launch pad, everything is in great shape. Don't let those clouds fool you. We are go for launch. The latest weather briefing just completed indicated that all weather parameters are green. We have a green board here in the control center, and everything has gone extremely smoothly in the countdown. About 9 minutes ago, a major milestone passed as the James Webb Space Telescope began the process and completed the process of receiving commands to transition from external power to internal battery power following the latest in the series of those weather briefings. Webb will remain on internal battery power until its singular solar array unfurls about 30 minutes after launch. Earlier, telescope controllers reported good environmental readings from sensors inside the fairing encapsulating the telescope atop the upper stage of the Ariane 5 rocket. And Luce, as we enter the most critical phase of the countdown, can you outline some of the upcoming critical activities as we head into the phase called synchronized sequence?
Yes, Rob. We are now reaching the end of this 11-hour sequence that we call the chronology, and that started yesterday evening. All systems here have been prepared for the final launch operations. And at the time being, it's rather quiet now inside the launch table and also inside the launcher. We were told a few minutes ago by the launch control center here that the launcher fluids and electric systems are ready for the final automated sequence. They are on hold now, waiting for the last weather report.
Wow.
Just 10 minutes.
I don't really want to buy followers. I want followers to be here that, just want to be here.
The beginning of this famous synchronized sequence.
Thanks.
All systems
Thanks for the
will be
offer.
ready for the liftoff. This sequence will first be run by the ground calculator, and then the onboard computer will take the lead step by step. And
That's all right.
The launch vehicle will be made autonomous from the ground system. You know that we have 2 tanks in each
No,
cryogenic stage.
I don't want 1,000
Stage
people in here pretending to be my friend Zeb. I want the 20 people that want to see this happen.
Of course,
I want to be famous at all.
From the hot environment we have here in French
First time
Guiana.
I've got one of those in a while.
However, these liquid propellants are at very low temperature, and because of that, slightly evaporate. And to ensure they are perfectly loaded at liftoff, their final loading and topping up will last up to 4 minutes before the launch. So that will be the beginning of the synchronized sequence run by the ground calculators. Then we will have on the fluid side the end of the topping up, the final loading and the topping up of the different tanks. And on the electric side, we will have the onboard computer getting prepared for the launch also, and it will be uploaded with the H0, with the H0 time, the time for the liftoff, which is today at 9, at the beginning of the window, 9:20 local time, 7:20 Eastern time.
And Luce, we're coming up on that final weather report. We expect all systems to remain green.
Overcast isn't a problem.
To confirm that
As long as it's not lightning.
Or 2 from now. It's a 27-minute ride to orbit from liftoff until the
That's a long rocket ride, but it's a long way to get to L2, so that makes sense. And then 3 minutes after it gets there, it's going to deploy a solar array. So again, Merry Christmas. We're under 10 minutes from the launch of the James Webb Space Telescope, which has been something I have been interested in for over 20 years. And these scientists have been working on for longer than that. Merry Christmas, and thank you for waking up with us this morning here at BOSA with the Big Top Outlaws community to see something truly stupendous begin in our understanding of the universe.
Hi, Rob. Well, so far, so good. We just received the last weather forecast. It's all green for the H0 that is forecast right now. What we checked was altitude winds, wind in the vicinity of the launch pad, and risk of lightning. So right now, it's a relief because the weather was a bit tough in the last couple of days.
The weather yesterday was the reason they had to scrub and move it. Because they were originally going to launch yesterday. They were going to launch like the 18th.
The synchronized sequence at 7 minutes before liftoff. Last operations that Luz described earlier before Webb and the Ariane 5 are going to lift off and soar into the sky.
Thanks, Raphael. We'll be back with you and Luz here shortly. We now have confirmation from Baltimore that James Webb is on internal power.
I am beyond excited to see what we get back from Webb.
We cannot forget that it is Christmas Day. 53 years ago, the astronauts of Apollo 8 completed their final orbit of the moon after reading from the book
and they gave a very controversial speech.
To billions of people.
They read from the book of Genesis, and it was seen as a First Amendment issue, which, whatever, just get over that thing. That was a hopeful day on a very bad year. 1968 was a watershed year in U.S. history, and it was a moment that just, who cares? The Earthrise photos that came back from Apollo 8 are the first images of the Earth in its entirety, with the moon in the frame, and it was amazing.
Going to be hearing all the critical calls from the DDO, the
I have a
manager.
turn to the video feed.
Who is Jean-Luc Voyer here in the launch in the Mission Control Center. There he is.
Turn my own audio down.
He will be calling the start of synchronized sequence.
That
all
better?
The critical countdown
Not a problem.
milestones. And we will be listening very intently for his calls.
I just like to make sure that I'm able to speak over the video if I have to.
Attention pour la séquence finale lanceur. Top. À 0 moins 7 minutes.
7 minutes.
And with that, we've entered the period of
Eddie didn't like the
sequence.
volume change, apparently.
You heard Luz Fabrichet just a moment or two ago explain some of the critical activities. The first one coming up.
T-minus 6 minutes and 40 seconds until James Webb launches to space. And I almost get a little misty thinking about just saying those words because it's
75 tons of propellant, 150
what we're going to learn
liquid,
as a
oxygen,
species
and
about
25 tons of
our
liquid
universe
hydrogen,
is about to be greatly
upper stage
expanded.
Loaded with 15 tons of propellant that will be the workhorse for a 16-minute burn to lift James Webb to its final orbit. At separation, some 27 minutes and 7 seconds after launch, James Webb will be at an altitude
then 6 months of pucker factor 100 to make sure it all works and can be aligned. Sometime in June, July, they'll start giving us images back.
Telescope, and more than 600 miles higher than the International Space Station. Webb at that point will be traveling about 21,000 miles an hour as it heads out to a highly elliptical halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
In a little more than 1 minute from now, we will see the 4 tanks pressurized at their flight level for the last tests before the ignition of the Vulcan engine. And in parallel, the electric system are also set in flight configuration. The onboard computer, the electrical power, as for the telescope, it will switch from ground to internal power 1 minute before the launch, 1 minute and 5 seconds before the launch. And we are going to see minus 6 seconds. At minus 6 seconds,
they'll fire
the
main
disconnection of the upper stage, these big cryotechnic arms you can see on this picture. Then, 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence to ignite the Vulcan engine of the main stage will start.
I guess it's important to note that this thing's not going to lift the moment it reaches T0. That there's going to be almost a 10-second period, whereas the Vulcan fires, they're actually in a scrub mode at that point. They're making sure that the Vulcan engine itself is turning on correctly before they light the SRBs, because they don't want to light the SRBs unless they're sure that the engine is correctly firing, the main engine, because the SRBs can't be turned off. So we're used to seeing, you know, SpaceX launches and ULA launches in a different way. It's a sequence start, but we're used to a lot of Falcon 9 launches where we just, boom, goes, right? It just goes at T0. It's like off the pad in 2 seconds. That is not what this is going to look like. So don't get a little nervous. Yeah, it's going to look a little bit more like, it's a good analogy. It's going to look a little more like a shuttle launch. You hit that initial point where it's going to kind of, and then go.
Will provide about 90% of the initial thrust off the launch pad. Will shut down and separate at the 2-minute.
So don't have that part pelt moment where you're like, why isn't it moving?
5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the T-minus.
It's just the nature of using the SRBs. Falcon 9, Falcon Heavy, it's all liquid fuel, so they can shut the individual engines down whenever they want. The shuttle was very much, you know, as Manny just made a great comparison, is an SRB-assisted launch system, and the SRBs are Roman candles. Again, they cannot be turned off once lit. It's like a firecracker. You light it, you have to run away from it, because it's not going to shut off. They're going to expend their entire solid fuel base, and then they'll be useless.
Coming up on the 2-minute 50-second mark,
but you can't turn them off.
Again, you're going to
be $10 billion on the line. $10 billion on the line.
The range operations manager, Jean-Luc Voyer.
The difference here between like a Delta 5 Heavy or an Atlas as well is that those configurations have different numbers of engines as well as number of attachable boosters, and those boosters are not solid. So
at the final couple of
the solid booster has always been a cost thing in the past, where it's been cheaper to produce them, but now that we're in an era of reusability, liquid booster systems are about to take over, because now you can get that booster back and refurb it and reuse it. The SRBs were recovered from a material standpoint for the shuttle, but they were kind of like recycled and then put back into play. But again, remember the SRB was one of the major problems for Challenger. The way in which the pressurized ring system worked on the SRBs, big problems. Was the major reason for the Challenger.
The flight will be in 2 phases. You will see the first part of the flight.
Everyone going outside. 1 minute 40 seconds until launch.
Part of the flight, the atmospheric flight, and the trajectory will be driven by to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform.
Yeah.
That is right next to the Jupiter Control Center.
One of these days, I will see one of these in person.
A 1-minute call from Jean-Luc Voyer.
Attention pour moins 1 minute. Top, à 0 moins 1 minute.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now. T-minus 50 seconds and counting. As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope.
There's a lot on the line here in the next 30 seconds. There's decades of work on the line here in the next 30 seconds.
T-minus 30 seconds and counting.
I can't believe this thing's actually happening. Yeah, literal, I have goosebumps.
Standing by for terminal count.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
Your engine light.
And we have engine start.
There she goes.
Decollage, liftoff from a tropical rainforest to the edge of time
That's a
itself.
clean leave of the
James
tower.
Webb begins a voyage back to the birth of the universe.
James Webb Space Telescope is airborne.
20 seconds into the flight, good pitch program reported.
Yes, way, Ted.
Vehicle performance is nominal.
Welcome back, Fish.
The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
Altitude 11 kilometers, distance 4 kilometers. Vitesse, velocity.
13 kilometers in altitude, 7 kilometers downrange. Traveling.
Thank you very much, Sister Claire, and my 2 years of French class. Already on the east coast of Africa at T plus 1 minute 30 seconds.
You can see at the bottom of your screen the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute 41 seconds into the flight, about 40 seconds away from shutdown
that can't
of the
be
solid
right.
rocket boosters.
It has to be that green X. There's no way it's on the other side. They have it marked Webb Space Telescope on the west coast of east coast of Africa, but it has to be that green dot. I didn't know reason why I said that like that. I'm stupid. Coming up on the separation here. Altitude is 56 kilometers at a distance downrange of 63 kilometers. It's a pretty shallow trajectory.
Everything is okay. Everything is normal.
2 minutes 15 seconds into the flight.
When the computer detects this threshold, it will.
There are your SRB SEP. Waiting for a good call.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at
pitching
an
over.
altitude of
He's
44
pitching up.
miles. The Ariane 5.
Yeah,
James Webb
I am a little excited.
5,000 miles an hour.
A little bit.
We have about 1 minute 5 seconds.
So
to
one
go
of the things you can
before
see in that
fairing
bottom
jettison.
picture of
That'll be
those
the next
kind of
critical
brownish
milestone.
orange areas, those are the communications relay systems. A lot of times those are ground stations and on ships. They can remain in contact with the spacecraft as it moves. NASA has done this forever. Everyone's done this forever.
Now the case, the satellite does not
Look
need
at how
anymore
close
to
to the
be
equator
protected
that this
and
thing is.
Webb does not need anymore to be protected. So each kilogram being very important for the performance of the launch, we are
We're coming up on the S1 SEP.
no more useful fairing.
And as Lise Doucette is
And let's go
explaining,
down
we're
to
getting
the
rid of it
floor,
because
in
it's
the
empty.
Jupiter Control Center to Raphael Chevrier of Ariane Space. Raphael, so far so good.
Hi, Rob. So far, so good. Everything is nominal.
There is your separation of the fairing. The James Webb Space Telescope is exposed to space. We'll wait for the confirm again.
On the yellow line, on the screen, we
La
have
coiffe,
confirmation of
the hat.
separation of the two solid boosters, and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going super good.
So again, the reason they're shutting the fairing, they're out of the atmosphere. It's extra weight you don't need, so get rid of it.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on
304 kilometers downrange, an altitude of 154 kilometers at T plus.
Control room.
They don't have it on the
There's your
screen.
Telescope ready to unfurl its wings, basically, and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
Trajectory nominal.
Trajectory is nominal. The report from Jean-Luc Voyer.
I can see that dude smiling under that mask. He looks pretty happy with what he sees.
The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Peru.
Trajectory remains nominal.
flight control is very smooth.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance.
That's a long
again,
burn.
You can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we
That's
are
a pretty
right
long.
on
I mean, it's a
course,
heavy
right
lift
down the
vehicle. That's a
pike, and
long
perfect
S1
trajectory
burn.
so far for the Ariane 5 rocket.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are in Kourou.
So they're saying that the Galileo tracking station, which is indicated on the map on the bottom, is taken over.
And then we'll have the
Keep hearing the word nominal in French. I'm good.
As you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the telescope will be separated more or less over this Malindi station, and this Malindi station will also acquire the telemetry.
So they're
data
indicating
from
with
the
that
telescope.
James Webb or that Webb Space Telescope that's separation.
And data on this animation, it means they are
It's
expected
a really
to
shallow
receive
trajectory.
the data, and it was confirmed right now by the launch operations manager.
Acquisition de télémesure par la station de Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned. And just a few seconds after that, the upper stage engine will ignite.
The 3-stage
and it,
rocket
will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit.
Again, thanks for hanging out this morning. It's a long ride to get 1 million miles from space. T+30 is our
11 minutes from now,
goal today. So we see these solar arrays, or have confirmation that these solar arrays have deployed for Webb.
Prepare James Webb for the initial series of commissioning activities that will lead to the deployment of.
So we're coming up on that S1 I misstated earlier. Now we're coming up on that S1 separation. I misinterpreted French.
About 30 seconds away from main
The
engine
initial
cutoff.
call was for the fairing, not for the S1. But we are now coming up on the end of that first stage burn. Trajectory remains nominal.
Trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Voyer, as we stand by for main engine shutdown and separation.
So why is it angling down? Because it's picking up speed using the Earth. So that it can skip off and head out to where it's going.
Extinction de l'EPC.
That's an S1 SEP call.
Opération EPC.
And that is an
And we
S2
have
engine
main
light.
stage shutdown and separation confirmed here in the Mission Control Center, and the ignition of that upper
Allumage
stage.
ESC.
And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition.
You can actually see the altitude coming back down a little bit as it picks up this speed, using the Earth. Actually shooting a little bit back down toward the Earth, letting gravity pick up speed for
space
it.
condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit.
You're
and
talking
right now,
about
everything is again nominal, as the DDO just said.
25, 26 minutes.
And a short
T
time
plus
from
25,
now,
26 minutes
the,
around there.
So-called
Is this engine burn?
sawtooth maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like a baby in a cradle. You
Yeah,
can
it'll start
see
going like
here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, it's
in space.
Folded and not
Just
yet
get where you're going now and work.
A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the sawtooth approach. And if you are watching carefully to these images, you can see this animation. You can see that the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the Mission Operations Manager, Carl Starr, who's at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars.
So we've shallowed about 30 kilometers on this S2 burn, and again, we're nowhere near the atmosphere. The carbon line is 83 kilometers below us, but they're using this lowering, this angling down at the Earth to pick speed up.
To prevent
it's a slingshot.
Due to the cool down of the telescope's composite structure.
You can see now the curvature on that yellow line becoming the green line, that they're going to start to even off that little bit of a dive they've taken. And that dive is intentional.
Will be powered on. This particular mechanism helps with heater control of the fine steering mirror.
And then you can see as the trajectory comes back in, they're going to again begin to gain altitude. And that means that they have effectively, as this curved line begins to come back up, they're effectively getting past the Earth at that point. They're getting outside of that orbital track that you kind of imagine of something going around the planet. They're effectively skipping the spacecraft off of Earth's gravity, and they've picked up speed, and they're leaving near Earth's orbit that you're accustomed to when you think of like the International Space Station.
James Webb's observations
already higher than the International Space Station.
We're 13 minutes 55 seconds into the flight. Jean-Luc Voyer, the range operations manager, continues to report a nominal performance for James Webb. And again,
so watch that altitude. We're 179 kilometers right now. And this is something I wish they'd be explaining. Why is there a down curve here? Now we're starting to pick up altitude again. So they've shallowed off, leveled off, and now they're going to start picking up altitude again. Relative to the Earth.
Altitude is slightly going down.
Altitude in space is a weird concept. You start thinking of altitude now as distance from Earth.
This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect. and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now.
Yeah, they're like watching, man. It's like right on cue. So the idea here is the vitesse, the velocity was about 2,000 kilometers per second when they started the shallow. It is now 4 times that. Part of that's the engine thrust, right? But that was significantly aided by this dip maneuver, this dip slingshot maneuver that they pulled off.
Around the Earth with an apogee, a very high apogee above 1 million kilometers.
Trajectory,
The number of times that I've said, really nice if they did this, and then like 20 seconds later in a space, oh, this is how this works.
185 kilometers in altitude, some 4,500
So
kilometers.
slowly picking up, and look at that curve as it gets away from the Earth.
More
It's
than 8 kilometers per second.
off and on its
right
way.
On the plot, right on the trajectory.
And that you can kind of see, if you can kind of visualize the altitude plot that they have there, that trajectory plot is, I know, Feast, I'm impatient because I just want people to explain the science of things. Sorry.
Will separate, observatory separation.
But you can kind of imagine that is Webb going away from Earth.
Starr, the mission operations manager.
Hopefully it's graphically represented well here. They're doing. I like the graphic. They're doing a good job with showing you relatively where Webb is. But I really hope that they start, as the NASA EYES program will allow you to do, and maybe we should see if NASA EYES has got it up. I should probably do that. See if we can bring up Webb on NASA EYES. I'll see if that's something we can pull off here.
To begin its astronomical observations.
Probably is not in there yet.
And again, as we mentioned earlier, at the time,
we'll see if they've got Webb in NASA EYES.
Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour.
EYES on the solar system. Launch simple mode.
We're about 8 minutes away.
Oh, it wants to launch the EYES app because I have it.
The stage
You'll
has
see some
performed,
apps flashing in the background.
planned.
I'll get that off the screen here.
No issues reported. The launch occurring at
'Cause I'm the kid who has EYES on
Greenwich
his
Mean
desktop.
Time, 9:20 Kourou time, 7:20 a.m. Eastern time.
Played
on
it
this
faster.
Christmas
Yeah,
Day.
I know. Our impatient society. I had a good conversation with my father last night about
The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in a kilometer per second, but
welcome to EYES on the Solar System, where you can explore your planetary neighborhood.
I would like you to not speak.
The telescope is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early phase operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave
It's populating things in for me, and I'm looking, but I don't believe that Webb is here. No, Webb is not in EYES yet.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is
If you've never
going
seen it,
towards its
just because I'm
preliminary
mentioning it,
orbit,
I'll bring it over the screen real
all
quick.
modeled in
EYES
advance,
is an application
in
where you can see
advance,
where everything
and
is.
carefully
You
choreographed
can zoom in and out of
maintained as a
planets.
quiescent
You can have a look at
atmosphere
where
and
individual
environment around
things
the
are doing their
telescope,
jobs.
for its ultimate separation from the
yeah.
upper stage of the Ariane 5
Ocean
rocket,
Surface Topography
which is
Mission,
about,
Jason
6.5
2 spacecraft. You
minutes
can look at this stuff in EYES. It's a downloadable app on your desktop. You can see Earth missions, solar missions, Mars missions, comets, everything you ever want to look at.
18 and a half
And give you
minutes
real-time
into the
positioning of everything. We actually used EYES when we did the Perseverance landing. EYES is a great app. Just look NASA EYES, you'll find it.
NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully.
So significantly increasing altitude now, still picking up velocity. Again, we're only at about a quarter of the speed this thing's going to be at the end of the day. Actually, no, that was a miles per hour. So what is miles per hour, kilometers per hour? Why is everything... Why can't everything just be metric and I've been brought up that way?
And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase.
Yeah, it's got a long way to go in velocity.
20-minute
We're about a
mark
sixth of the
into
velocity
flight.
it's going to be at eventually.
Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
After the cutoff of this main engine, as you said, Rob, we will have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this small ballistic phase, all the requirements from the telescope are fully met, and that at the separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope.
So she's speaking as a launch provider. The mission ends when the payload is deployed to its designed orbital destination. At this point, the L2, the halo elliptical orbit is going to be in at the L2 Lagrange point. So from Arianne's perspective, they have an obligation to deliver the payload there in the conditions requested. Speed, trajectory, all these factors. So this ballistic burn phaser she's talking about is designed to achieve those conditions, basically meet the contract conditions for Arianne.
All parameters nominal as reported by.
So now the James Webb Space Telescope, relative to Earth, even though it's getting further and further away from Earth, is above the west coast of Central Africa. Now almost double, actually more than double the altitude it was when it finished that shallowing using Earth's gravity to pick up speed. It is now more than double its altitude at that point. It's picked up another 1,000 kilometers per second of velocity. So we're about 12 minutes away from this thing being where it should be at the L2 point. And actually, sorry, not at the L2 point. It's going to take a month to get there. We're about 11 minutes away from the deployment of the solar arrays and ensuring that this thing can get electrical power from the sun and get off its battery power. Which is an interesting thing because you don't want the optics exposed to the sun, right? But you want the solar arrays exposed to the sun so it can actually generate electrical power.
With the yellow plot over the green one, that is the expected one.
So Ariane's going to deliver the Webb telescope to a position at which point the space agencies will take over operations of the telescope itself to get it to where it's going.
Smooth flight control.
There we go. If you look at the bottom right, you can see that altitude beginning to increase as Webb Space Telescope gets further and further away from Earth.
And again, as we've mentioned before, everything nominal reported by the range operations manager. As we've mentioned
way back in
before,
Apollo,
this is a
it would have looked like a
long
very
hill
similar
for the
trajectory,
James
except it
Webb
would have
Space
been pointing at the
Telescope,
moon,
put
and
it
it would
at
actually
the
been a little bit of a
proper
curved
position in the
line,
sky, so
plotting
that it
between
can
the two
escape
objects.
from the Earth, basically head beyond the moon towards its final orbit for its commissioning
Beyond the
activities
moon.
that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
To give you an idea, it took a couple days for the Apollo astronauts to get from the Earth to the moon. And it's going to take a month for this thing to get from where it is today to where it wants to be, the L2 point. So beyond the moon is it's really beyond the moon. Which is why it can't be serviced by, anything we've got. So we don't have any crude capability that can get out there. So anything that goes sideways with this potentially has to be serviced,
it will be on
via
its own.
robotics, via some sort of automation.
And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore.
So the S2 still burning here. Still picking up speed.
1 minute of
Now 750 kilometers, so a tripling plus of altitude since that little dip slingshot maneuver.
Stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
So that milestone on the bottom of your screen says Extinction ESC-D, and I'm imagining that's the S2.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn.
Yep, that makes sense.
Now about 30 seconds away from upper stage cutoff. we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Wait for that call up.
JWST.
Here's your second stage cutoff.
Tous les paramètres à bord sont normaux.
The extinction of the shutoff of the cutoff of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting
that means it's
Webb
talking.
Separation at the 27-minute 7-second mark here into the
So
flight.
1 minute, 7 seconds.
Just over a minute from now, Springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave.
This is in KSP. When you screw up and you fire the S2 remotely on accident, it slams into your highly sensitive space observatory. That's what happens to me a billion times. Like, that's not the one I meant. But the object collision avoidance maneuver is to make sure these two things don't slam into one another.
Pollution towards the telescope.
1,310 kilometers
And we're
above the
about
Earth now.
17 seconds away
Or
from
distance
Webb
from the Earth.
Separation.
About 7 seconds from it, Mark. I think they're zooming in. So that entire fairing design there, as they mentioned during the initial broadcast phase, is custom designed for Webb.
Webb Space Telescope. Go Webb!
So that's Arianne celebrating that they've done their job. That Webb is separated from all of the launch vehicles here.
We do have confirmation of observatory separation. The James Webb Space
Now
Telescope,
Baltimore
amidst applause
spacecraft.
here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery. It was a perfect ride to orbit. And all of the separation sequence events are running in good fashion, according to the telescope controllers. And there is the view.
That was the actual view of this telescope from the S2. What a freaking shot!
Gently away from its launch vehicle.
What a shot that is. That's from the S2. Looking at Webb.
Fantastic pictures of this telescope.
Go Webb, go Webb.
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves.
Unless,
to
I mean,
its
I
warp
could probably go out in the backyard
about 1 million miles away
and
from
maybe
Earth.
see it.
Yes, you're right.
If I've got, my telescope out. I could definitely see Saturn, so I can probably pick this out if I'm looking
Now
for
we'll
it.
be hearing shortly
But
from
yeah,
the mission operations
we're not going to have
manager
any
of the
more
Space
camera
Telescope
views of this
Science
thing unless
Institute,
we put an
Carl
observatory
Starr,
at it.
who will be calling out
This
the
is their last
procedures
chance to see
that will
Webb.
lead to the deployment of Webb's solar array.
So the T-plus clock is gone off the upper screen, but we're rolling up on about 4 minutes, I believe, until we should start hearing conversations about, oh, never mind, look at that. Look at that.
And down in the fishbowl where there is jubilation, let's go to Raphael.
That looks like a
of
solar array
Ariane's Boss.
deployment to me.
And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed.
They did it so we can see it.
Webb now, has its
How
array
awesome
out.
is that? That is the solar array
Confirmation
deploying.
that it is power positive.
And oh man, that's awesome. Power positive means it's generating power. All good things.
J'entends pas ce qu'il me dit. Il m'a appelé ou pas?
She's about to leave your frame. But we got to see that solar array deploy. I was about to say, it's going to be about 3 minutes. I know,
There it
seriously.
is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Arianne Spas.
Literal, like,
This is
tearing
it.
up a little bit.
We have witnessed and the confirmation that Ariane 5 have safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the sun, but honestly, I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Ariane Space, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the team involved in the flight. Really, there is no words to describe the immersion that is happening right now in the fishbowl. So all I can say is good luck, Webb, and bring us incredible data from the deep universe.
Indeed.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou.
There they are.
Today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations. Luce Fabregat, it was a smooth ride to orbit. Everything went by the book, almost like a simulation.
There's not going to be much more from Webb for a little while. It'll be checkpoints
Thanks to you, Rob, and
over the next month.
Great achievement. I have many faces and names now coming up to my mind, and really you can be proud of what was achieved on both sides of the Atlantic Ocean. Thanks a lot.
I don't know why I just did that. I hit the wrong button, probably.
Jubilation here in the control center. You're looking at Jean-Luc Voyer, the range operations manager.
So it's a pretty amazing day.
Quite a Christmas present for the world's astronomers. As
it is. It's a Christmas present for just more than the world's astronomers. It's a Christmas present for humanity, even though they don't know it yet.
Space.
Oh, that's
With
from
that,
KSP.
We're going to go back to the floor now.
So we're going to wind things down here because it is Christmas Day, right? And I really appreciate those of you who have come out to watch what has been an excellent start to the life of the James Webb Space Telescope. Really, just amazing stuff. So, again, I post space stuff all the time, too. Look at her. She said it, too. I post the space status stuff all the time in my channel on our community Discord. If you are unaware of where we gather for that thing, let's pop a link in there for you guys. That's where the big channels come together. My channel is called Fixer Industries. I will be posting the information, and Maney will be too, because he's an enthusiast about where we are with Webb over the next month, where they are in their shakedowns. There's just a lot of good news this morning for a program several decades in the making, and for a great ability for us to have deeper insight into not only the origins of our universe, but where else there may be life out there. Huge thing to be able to spread the IR spectrum down to the layer of microns it's going to, that we can actually see if there is water on some of these Goldilocks zone planets. Congratulations, Ariane Space. It's a hugely stressful launch, probably the biggest one of their entire lives this morning. And as it's been stated, the work's just starting for the people in the Space Telescope Center in Maryland at Johns Hopkins. But get to your holiday activities, everyone. Hopefully you've enjoyed hanging out here this morning. From the bottom of my heart, as always, thank you for giving me time and attention, for the sharing of knowledge and information. We should start seeing our first images from Webb this summer. And of course, follow the NASA astronomy picture of the day, because those will start to become Webb images at some point this summer as well. But enjoy your holiday, your time off this weekend, your time with your families, and your gifts you're going to open, the meals you're going to have, and thank you very much for being a member of my family and sharing what is a very big day with all of us together this morning. We are going to roll out of here and get to your gifts and get to your cookies, get to everything else that's going on in this fantastic Christmas morning for science. And I will talk to you all very soon in everyone else's channels and I hope you have a great Christmas. Thanks for being here. Number 98, my friend, rolls it in at the end. Thank you very much for being here, everybody. Go back to bed, Manny. I will talk to you all later. Have a great holiday. Normal streams for me next week, and I'll see you all later.
Be excellent to each other.
No rocket was live. We're gonna Raiders. Stand by.